On today's episode, I print a modified handle for my portable electronics workbench so I can mount this extending arm for my iPhone. That's going to allow me to film projects that I do right here. I'll show you how I made it, and I'll show you a demonstration on today's Filament Friday. Filament Friday is brought to you by the generous donations of my Patreon supporters. Thank you so much. Also, those who use the Matter Hackers and Amazon links in the descriptions of my videos to buy stuff, that helps too. Thank you. Here's the handle that I designed in a previous Filament Friday for the portable electronics workbench. So I brought in a cylinder to modify this, and this is what I'll mount to. So once I have that, let me zoom in here. And this is the cylinder I'm going to use, but I'm going to have to resize this. This is actually 20 by 20, so I actually need to resize this down to 15 by 15, so it's not too big. I could have left it bigger, but it didn't need to be that big. So I downsized it to 15 by 15 and then put it back in the corner where I had it. And it's not perfectly centered, but you know what? It's close enough. It doesn't have to be exact. I just didn't want any gaps. So once I had that, then I brought in another cylinder, only this time a hole. And this needed to be a 7mm hole, because that's what the bolt will go through. So I'll make it 7mm in diameter. Now I need to make it taller too, because this is going to go all the way through that other cylinder. And then I need to drag this over to the center, so the two are centered to each other. So once I get that in place, hold on, let me adjust this. So let me move it over here, and then you can see it there. That's better. So then I just move the hole into the center of the cylinder and drop it down so it goes all the way through. And then I need to align these, make sure they're centered. So I'll use the align tool, and I'll click on the dots to center in the X and Y direction. And then once I've got that, I just need to grab everything, the handle included, and group them together as one solid print. So I'll click on Group, and they're all together. And it's ready to go. So here's another view of it. So the next step is to just export this as a .stl file so I can slice it and then print it on my Makerfront printer in PLA. So let me export it as STL, and then I'll import it into Simplify 3D. So I angled it like 45 degrees on the bed and then clicked on Edit Process Settings, chose my Makerfront profile. I'm going to use PLA and set it to 50% fill, so this is fairly strong. I'm going to use a 0.2 layer height, and then 3 top and bottom layers and 3 perimeter shells. No additions like skirt or brim or raft. Infill, like I said, 50%. Support, didn't need it. Temperature, 50 degrees on the bed, 215 degrees for the extruder, or the hot end. I do have a cooling fan going, and then 60 millimeters per second for the speed. And once I did that, I just clicked on Prepare to Print, and this thing was sliced, ready to go. And it said it would take 2 hours and 21 minutes and just under 10 meters of plastic. I used this prototype HTPLA that you can heat treat from Proto-pasta. Now I didn't heat treat it and it still came out pretty good, but I guess I can make it stronger if I did. And the print just printed beautifully. It's very smooth. It laid down nicely. I'm really happy with this filament. And here it is all installed. So let me go through the steps and I'll show you how I installed this and set the whole thing up. Here's the old handle. I already loosened up the screws that are coming from underneath, and then there's 2 little nuts. So once I got the old handle off, I just needed to take the nuts out of it and then put the new handle in place, and it all lined up. Everything looked really good. So I just got that in place and then brought the screws up into it, and the holes on the handle was just slightly smaller than the screws, so the screws actually screw into the handle, and then the nuts are there just to hold it. So I used a ratchet underneath just to finish tightening them, and then once that was in place, I checked the handle and it was solid. So now I could mount the extension arm, and this just took 1 screw which went through the 7mm hole, and then the handle screwed onto it. This was designed to go onto a tripod, and so it fit nicely, and then I just used a screwdriver to tighten it up the rest of the way. Now I was off just a little bit of positioning, so I just kind of grabbed it and twisted it. And this thing was holding so tight, I really had to grab it to twist it to get it where I want. So now that it's mounted, I just need to install my iPhone. I put it on this spring-loaded clip, position it so it's kind of centered, extend the arm, And now I can film hands-free. Let me show you a demonstration of what I have in mind. So what is a microcontroller? Well, someone may hand you one of these, an Arduino module, and say this is a microcontroller. But really that's not accurate. This is the microcontroller. This is an Atmel microcontroller, and on an Arduino it's been pre-programmed with an Arduino bootloader that'll communicate with the Arduino IDE. So the Arduino is kind of a whole development system, starting with an Atmel microcontroller. The Arduino bootloader is programmed into this guy using a hardware programmer. That loads the bootloader, and then that bootloader can self-program its own flash memory through a serial connection to your computer. So what then is a microcontroller? Well, let's look at it on here. A microcontroller has similar parts to a computer. There's a microprocessor at the heart of it. There's a hard drive or flash drive on your computer. There's a RAM, and there's a BIOS, the bidirectional input-output system. This is what connects the microprocessor to the serial ports, the computer display, keyboard. That's your BIOS. So if you could take all these together and group them into one single small chip or integrated circuit, that's a microcontroller. So do you need this to run a microcontroller? Well, it makes it easier, but no. Here's an Arduino I built on a breadboard, and it's got all the same connections. Here's the microcontroller. Here's a serial communication for loading to the bootloader, and that's right here on the board. Here's the crystal with a couple of capacitors. That forms the oscillator or the heartbeat of the microcontroller, and that's right here on the Arduino board. And the power supply, which gives the 3 volts to 5 volts, well, that's handled by this little module here. And of course there's the LED, which everyone seems to flash as their first program. Well, that's right here. So I've built the same circuit on a breadboard based on the microcontroller. Now what about 3D printers? What do they use? Well, they use an Arduino module as well. Only they use a larger one, typically an Arduino Mega. It has a larger microcontroller with more I/O pins, but other than that, it's the same development board. Same serial connections, same LEDs, same crystal, same power supply. In order to make this control a 3D printer, then you need the shield, the ramp shield. This has drivers for the stepper motors, connections for the end-stop switches, the temperature sensors, and also FETs to control your heated bed, your hot end, and your cooling fan for the filament. And sometimes these two boards are designed in as one single board, like an MKS base or a GT60 board. So there's all kinds of designs out there, but basically they all start with the same thing. This chip right here, which is a microcontroller. So there you have it, a real simple solution, 3D printed, to give me what I was looking for. And I want to do more videos like this, so if you like what you saw, let me know in the comments below. So that's it for this week. If you like what I'm doing here, check out some of these other videos. If you want to help support the channel, $1 a month to Patreon really helps. And if nothing else, please subscribe. Click on my logo down here. That's it for this week. I'll see you next time on Filament Friday.